Okay, so now we know that we presented two applications to you, right? So one was an office application, which was heavily used by 9 to 5, typical office hours, and not much activity during and before the day. Before and after the day. And a green type of application that I showed you, like actually, I can just maybe just circle this with, let's see. So let's create a boundary over here. So there's this one application, and this is the usage pattern for that. Spiky traffic based on the news site, and then the one below over here with the orange thing. This over here is the office application that has two different usage patterns. What is a usage pattern? It is the way an application is typically used. And when you're designing containerized applications, you're paying attention to the usage pattern of your application, right? Is my application used every day, or is it used once a week? There are some reports that are run in companies that are run weekly, monthly, quarterly, yearly, right? So that could also be an application that you would run on Kubernetes. Or it could be an application like, let's say, you want to run a banking application. Like, let's say this is a bank, and we want to run an application so that we could do the business of the bank, right? We want to make deposits and withdrawals. And so in that sense, right, we first need to understand what is the usage pattern of our application, right? So let's say, actually, you know what I'm going to do? I'm going to start to create a key ideas section that we're just going to keep adding to. And this key section, let me see if I can just put it over here. So this is going to be key ideas that you want to take away from these lectures. So the first thing we said is the state of Kubernetes cluster is very dynamic state, right? And what this means is that containers come and containers come and go all the time, okay? All the time. So imagine like if you had a camera and you took a snapshot of our cluster, you would get a picture that looks like this, right? And a minute later, you took another picture and all of these green boxes and the orange boxes could change. Why they could change? Well, I've got somebody who's managing this cluster, and they are not, willy-nilly just issuing commands to scale up or scale down these containers. They're looking at something called a metrics server, right? And they are responding to alerts, right? And I'll talk more about how that actually happens in real life. But suffice it to say that the cluster is being managed by somebody who's sitting outside the cluster. They're looking at the world and the events that are happening, and they're responding and issuing API calls, right, to the master node. And the master node then sends the calls to the kubelets, and that changes the picture of the cluster. So that's very important to know. The other thing that you want to keep in mind, which is a key idea over here, is that consider usage pattern of your application. Okay, am I a predictable pattern, which is what the banking or the office application look like, or am I a spiky, random? Maybe you can just call it. What should we call it? Sporadic. Whoops. Let's just call it sporadic spikes, right? Can I tell when I will need to go up or down in terms of the number of containers, right? So consider the usage pattern of your application. Understand whether you're building it for something where you know what time you need to bring up the number of containers, what time you need to bring down the number of containers. Okay, so that's very important point to keep in mind. Now, back to our main topic: how do applications inside a Kubernetes cluster talk to each other, right? How do I get an orange guy to get to the purple application. So we're just trying to answer this question. How does this talk to this? Okay. So because of the dynamic nature of the cluster, imagine if there was a way that the orange would have to know where the purple is at, right? Is it running on worker node 1? Is it working on worker node 2? Or worker node 4? Or it could even be on its own worker node, right? The container is running inside the worker node, right? Inside the worker node. So the state of the cluster is changing all the time, and we are finding it very hard. So imagine, like, this is kind of like saying, imagine you checked into this cruise ship, and you wanted to talk to this purple guy, but the purple guy did not like the room that they were assigned to. So they talked to somebody and said, you know what? I don't want to be here, please. This room is not properly cleaned or something. I don't want to really stay here. Can I please move to worker node 2? And imagine that they get their wish and they say, okay, fine. You know what? We'll move you to room number. Actually, you know what? We don't have space in worker node 2. Well, let me just put you in worker node 4, because I have some other purple apps running there as well. So then the problem is, since we said that the way the containers fit into our worker nodes can change all the time, it is very hard for the orange guy to keep track of, well, should I be sending my network traffic here? Whoops. Should I be sending my network traffic here? Or should I be sending my traffic here? So in order to resolve this problem, there is a concept in Kubernetes that you must understand. And that is a very key concept. And that concept is of a service. If you remember, like we talked about 2 people that we've already employed. We have employed one person that stands in front of every room, and he's called a kubelet. He lets people come in. He lets people go out or go away, right? And then we have another person in every one of our rooms, guest rooms, which is worker nodes. That person is called a proxy or a kube proxy. Okay, kube proxy. Whoops, kube proxy. Kube proxy. So this kube proxy thing is there for making our applications talk to each other, right? They kind of keep track of what is going on in the cluster, and they help you reach out. The job of the kube proxy is not to create more containers or delete containers. The job of kube proxy, because it is really a network proxy, right? It is a network proxy. The job of kube proxy is just to basically have your containers talk to each other. But there is the third thing that we are now talking about, which is this service. Okay, so this service, let's say we employ a special kind of service. Let's say this is the third thing, and the job of service is to help us kind of route our communications. So one way we can understand that is, this is the person who would carry your communication over to different rooms. Okay, so we don't allow applications to talk directly. We just basically have created a service. And the service person, they have a register. They have a list that they maintain. They know who is in room number 1. They know who is in room number 2. Okay, and they know who's in room number 3, and so on. Okay, so they keep track of, okay, which containers are running here, which containers are running here, right? And then which containers are running here. And they say, hey, let's not have everyone reach out to everyone. Let's have basically, please talk to us, and we will join you to the right party. So imagine this is, not a direct point-to-point communication, But the way you've got container number one, C1, it wants to reach out to container number two. So what I really am going to do is I'm going to have them talk to the service, and I'm going to have the service talk to container number two. The reason being that this container can come and go at any time, which means that I don't want my containers to talk to each other directly, because then it becomes a maintenance problem. Why does it become a maintenance problem? Because remember, the state of my cluster is very dynamic. If the whole thing just stayed pretty common, I would probably consider allowing containers to talk to each other. But because things can come and go in a matter of seconds or minutes, I'm going to not allow that. I'm going to require that everybody reach out to an intermediary party and have that party go and talk to and take your message. Okay, so maybe they are kind of like a, like a waiter at the restaurant. Okay, you don't talk from one table to another table. You reach out to the waiter and say, hey, can you please pass this message? And the waiter actually knows who's sitting at what table, if that kind of makes sense. So we're going to take a pause here, and we'll start back.